Hello, everyone. Today I'm going to talk about the communication systems in AVs. So, you know that so far we talked about we covered some introduction to signals and systems. We went through the sensor technologies and sensor fusion. We went through control systems, and this is the last lecture of this training session. Um, about the communication systems. So now, for communication is essential for one of the main components in AVs because you will see that in the slides that it connects all the parts of the of like sensor integration inside the vehicle, communication of sensors, as well as some interaction with the environment of around the vehicle. Okay, so that is what this is also a key component in the autonomous transportation and especially in AVs. So the goal of the learning objectives of this lecture is to have you have some understanding about the fundamental principles of communication systems and different types of categories of the communication that we have for the technical part of it in terms of the wired and wireless communication and um, and then differentiate between internal communications and external communication and then talk about some real world communication applications and then the importance eventually I will talk about the importance of cybersecurity and privacy challenges in AVs. So now when we want to talk about the communication system, the first question is what is a communication, all right? So if you look at whatever you are doing or we are doing in our daily life is has the communication involved in that. So when we go shopping, when you go to school, and you talk to some friends, so it has some sort of the exchange of information between two people, between even when you are working with your uh, cell phone, with your laptop, it has some sort of the communication. Now, now, when we want to have a communicate, like a definition about that, communication is the process of transmitting information or exchanging information from one entity to another. Now, when you want to transmit this information, some medium or some what we call it communication channel is required. Okay, so this is what that kind of the exchange information happens through some medium. Now, each communication has three main components. So it has a transmitter that it generates information and sends information. For some technical application, they encode it because you want to, make sure that your data, and that encoding is for two purposes. One is to increase the security of data, and another one is to make it understandable for the other entity. So the second part component in a communication system is a channel or medium, which it carries the signal, right? How the information from one entity is carries to the other entity. And we have a receiver. Receiver is also another component that it receives information, decodes and interprets the information. Like when you talk to someone, you use like certain language. So that is where you have a transmitter, you encode it. It codes like if people talk in different language, but they want to communicate, and there is a common language like English, they encode it and then communicate it to each other. So we have a transmitter, receiver, and channel. So in transportation system, we have vehicles, traffic signals, roadside units, control centers, pedestrian. They communicate through networks that we're going to go in depth and talk about it. So now, autonomous vehicles, they have like extensive communication network, which happens inside the vehicle between the sensors and all the elements that they are connected, like everything mechanical, electrical, and there is another communication that happens externally between vehicle and its environment that we're gonna talk about it more in detail. Now, when we talk about communication in a technical side of it, we have two entities that they communicate. The medium, the infrastructure that they sense the information or receive the information, that is critical, right? And it's like transportation, which requires roads and other parts. So the infrastructure is critical for communication as well. So we have two main infrastructures for communication. One is what we call it wired medium, or it is called wired communication. Another one is wireless medium, right? Or we call that kind of communication wireless communication. And both of them are critical for autonomous transportation, right? For AVs. So now the wired communication, it's actually the communication medium is a physical path, right? So this means that we have a transmitter and we have receiver, and they are connected through some physical channel, right? And that carries information from one location to another, or from transmitter to receiver. So there are some different ways of this kind of the physical communication. So the common media in the wired communication, it's a fiber optic cables. And now the data in fiber optic is transmitted through lights, right? And this is what it's a super fast um, like technique, or super fast medium. And that is what we call it, that it has the very high bandwidth. When we talk about the bandwidth, it shows that how much information you can exchange between transmitter and receiver, right? So, and it is useful for long distance communication, and it has a less signal loss because you have a medium and then you send a light on that. So then we have copper cables, which is like Ethernet twisted pair cables. It covers shorter distance, and it used like inside some cabinets and buildings. So you may have seen that a lot. And another medium is the coaxial cables that sometimes used for CCTV and some certain security systems. So now these are physical infrastructure components for the communication. Now, if you take a look at here in this part of the slide, I have some example of the copper wire, which has a plastic, it has a metallic shield, it has central core, and these are copper fibers or copper wires that they actually exchange information, and these are mainly the wires. So, but for fiber optic, so the core of the cable is a light ray. So it's a fiber core, and the light will actually move toward that. So here, this table shows the different type of uh, medium that we have, like fiber optic, like twisted pair cabling and coaxial, and you can see that typical bandwidth. Like here, typical bandwidth for fiber optic is less than about 10 gigahertz, and that gigahertz is like the frequency, and we have set 100 megahertz and 1 gigahertz. And you can see that coaxial cable is faster than twisted pair, but the fiber optic is much faster than two other categories. However, even though it's much faster, it gives like most bandwidth. It's the fastest communication, and it's immune to electromagnetic interference or radio frequency interference. These are some effects that can increase the loss in the signal, especially when we have wired communication, and these two are got affected. You can see that they got affected by that. But since we have a light in fiber optic, is not getting affected by EMI and RFI. However, it's the most expensive infrastructure. So it's like, and it's difficult if something happens, or some part is like broken, anything. It's difficult to repair. But again, that's one of the way to use for the wired communication. So there are some applications of wired communication transportation, for example, traffic management centers and central control facilities, like monitor traffic conditions, control traffic signals. So these are connected through wired communication. There might be some traffic management centers that they are connected through the wireless. But the main advantage of wired communication system is that they are super fast, because for the wireless communication systems, there are some issue with the interference and some loss. So that is what. So mainly the applications that they require higher speed and more real-time signal, they use the wired communication. So adaptive signal control systems are like real-time signal timing adjustment and communication between intersections, data exchange with control center. These are actually some applications that they use wired communication, and CCTV and traffic monitoring, like um, the security control camera, and those camera, they, since you are feeding the video information, so that requires a very high bandwidth, and that is what mainly they are connected through the fiber network. Okay, so then another communication that we have is a wireless communication infrastructure, right? So the wireless communication is that, like, between transmitter and receiver, we don't have any physical actually cable or physical connection. So everything, like connection between the transmitter and receiver, or between devices that they connect together, is through some radio frequencies, it's through some electromagnetic waves that we talked about it in the signals, like radio waves. So then the wireless signal, actually, those signals, they will transmit the data or information through the air. Now, why is it important? Because in transportation systems, so vehicles are moving, right? Now, if you want to think about the wired communication, the difference between wired communication mainly and wireless communication. So wired communication used when you have two entities that they are fixed in like some certain locations. For example, you have traffic light, and traffic light is connected to the control center, right? So you can simply connect it through through the wired communication because you're not going to change it. You're not going to change the traffic light or move it from one location to other location, right? So, and since you have fixed environment between transmitter and receiver, then we can have the wired communication, and that will help in having a faster actually data exchange. Or even when we have a camera installed on the traffic lights or any part of the streets. So those cameras, they are fixed, they are not moving, all right? So, and in order to have accurate and high bandwidth, because like many of those cameras, they are capturing the like images in a real time. So then they need high bandwidth, and fiber optic is the best solution for that, okay? So, but for the transportation or autonomous vehicles, we have those some vehicles that they are moving, all right? You cannot connect a cable to the vehicle and then have it moving to certain road or passes. So, and they exchange information between the infrastructure and they exchange information with each other, which we'll talk about it. And that needs to be done through wireless communication, right? And again, this is essential for vehicles because we cannot have them physically connected to cables, right? Now, when we talk about the wireless communication, there are different technologies, and each technology has its own application, right? So we have Wi-Fi. It is a short range, high speed wireless communication, and it's typically used for local data exchange and like infrastructure connectivity. So there is a Bluetooth communication, which is a very short range. You all may have used that. It's a low power communication, and it's mainly used for device to device. So like in your car, you can connect to your car through the Bluetooth to like hear something or like have a call. But it's just because you're sitting in a car and the Bluetooth of your cell phone can get connected to the Bluetooth of a car, right? And this is what we have for the Bluetooth. Then there is a DSRC, dedicated short range communication, is a low latency vehicle communication and designed for some safety critical scenarios. That I will talk about it. And we have cellular, like what you have in your cell phones, which is like 4G, 5G, CV2X, either the wide area wireless communication, so it can cover the a wider range to connect the vehicles to infrastructure, to cloud system, and other vehicles. And then we have satellite communication, right, which is a global satellite-based communication, and it provides precise vehicle positioning, right, navigation, and some timing information that they are the core of AV localization. Okay. Now, this is like an example of different wireless technologies. So we have long range for vehicle to network, and you can see that 5G, Wi-Fi, GNSS, which is a satellite, or LTE, Wi-Fi, and satellite is used for vehicle to network, and there are some shorter range of some DSRC, ITS, G5, low latency. It's for, and like this one has a higher latency, or like latency is like a data, and it can send or transfer larger data, okay? And it's a long range communication. So here we have lower latency. It's for safety critical, and like for proximity, like when you have the vehicle to vehicle or vehicle to infrastructure. We'll talk about that. And also we have another approach like LTV2X, and that is for the short range vehicle to everything, like we call it vehicle to everything communication. All right. Now, we talked about the wired communication, we talked about the wireless communication, and now in AVs, essentially we have two kind of communication. We have internal communications that it's the communication that happening inside the vehicle, right? And it's a data exchange or communication between sensors, between perception system, planning system, control system, and actuators that we have like brake, steering, and throttle. So all the parts that we talked about before this lecture, so we talked about individual work of each like sensor fusion, control system, and now all of them they are connected to the communication. And it's mainly uh, through the cable because that communication has to be super fast and it has to be reliable and with less latency. Okay, so the wireless communication has the higher latency than wired communication, and like some technologies for that is like CAN bus, which is controller area network, automotive Ethernet, and in-vehicle networks. These are something that we have it as the internal communication media for AVs. So this is an example of like connecting different parts in an AV, like lights, like wiper lock, and roof, heater, power seat, powertrain control. And you can see that there are different categories. Like we have CAN, they are connected through CAN, they are connected through like flex ray or LIN. So which they are all actually the communication, wired communication. And this is how everything is connected together. Now, the autonomous vehicles, we have external communication as well. So external communication is what we call it the data exchange between vehicle and its environment, right? Now, the environment of AV is dynamic and there are different entities that it can communicate. So AV is the external communication in AV is the communication between vehicle and other vehicle. It is called V2V. Between vehicle and infrastructure, it is called V2I. Between vehicle and pedestrian, which is V2P, and between vehicle and network or cloud, which is V2N. So, and actually this enables like this kind of the external communication along with all those sensor processing because the internal communication, all the sensors they get information from cameras, lidar, radar, and that's a huge like amount of data that comes to the processing and control unit. Now they are all connected through wired communication because a fast communication is required. And then vehicle will have this wireless communication, all right, in external because it cannot be like physically connected to other vehicles or physically connected to infrastructure or to pedestrian and network. And that is what the communication media in external communication is done through DSRC, cellular, and satellite, which is mainly for GPS. And it actually helps because like the sensors will give some information about what's going on inside the system and around the vehicle, all right, like the camera and some sort of the like a certain areas around the vehicle, they can just give that information. But having the communication with other vehicle or infrastructure, it will extend the perception of the car and in which area it's working. Like if the pedestrian is getting close to it, so the camera may not detect it, but in the like a larger range, there might be that communication can help the perception system of an AV. So, and this is what you can see that like all those how different kinds of this vehicle communication, they can have the vehicle to vehicle communication to network to pedestrian to infrastructure, like getting connected to the signs or to the traffic lights, and how these are this helps the perception. Now, traditionally, civil engineering, like students or designer or engineers, they design roads, intersection, bridges, traffic signal, and pavement uh, markings, and many of them they were actually fixed, or what we call it, they were static. But the modern transportation system, now it requires data exchange between vehicle and infrastructure. Now everything is dynamic, right? So we have real-time signal control. So there is a traffic monitoring and safety alerts like smart corridor management. So that takes the static infrastructure to some intelligent infrastructure. Like for example, traditional infrastructure, we had like they were like fixed signal timing, static signs, manual traffic like studies, or road geometry only. But in smart infrastructure or intelligent infrastructure, you have adaptive signal control. So digital message boards or real-time traffic data and road and data network. Now, civil engineering, they can design signal phase and timing systems like roadside units, smart intersection, and connected corridors. So, so we talked about those V2X, V2I. So I'm gonna have a quick review of like quick information. What are the applications of each of them? About those different kind of the vehicle to the environment actually communication. So we have vehicle to everything. This is called like V2X. It's actually communication framework. It's everything. It covers. It's like an umbrella that covers all other vehicle to like pedestrian infrastructure, network, and vehicles. So and it's actually a framework that enables vehicle to exchange information with other vehicles, infrastructure, pedestrian, and then you can see it over here. And now, the main goal of this V2X is to improve safety, traffic efficiency, and and overall, it will enable cooperative and connected driving, because all these entities and components, they are connected together, and they will cooperate together. And it will support the perception and planning, right? Because once the AV receives information regarding some sort of the traffic congestion somewhere, or some crashes, or anything that happens somewhere, it can affect the replanning, like finding another route for um, for the vehicle. So, and it's not directly goes to the countries, like this kind of the external communication of vehicle and environment, it goes to the perception, and that perception eventually goes to control, and control system in the inside the AV will control the vehicle actuator. And V2X does not directly actually affect the um, like the vehicle control. So everything goes to just perception and mapping, and eventually the the output of those systems goes to the control system for the decision making. But that information helps a lot in the control side of it. So we have vehicle to vehicle, which is what you see that vehicle they communicate with each other, and and they can exchange information such as the speed, position, direction of travel, and their kind of the acceleration and braking, all right, situation. So these are the information, the exchange information, such as this different actually signals, and they exchange information, they work together or cooperate together mainly for safety and to prevent crashes, like don't get closer together, or and if there's anything happening around, they can send that information, and it like it can generate some signal, some alerts, like forward collision warning, like if a vehicle ahead brakes suddenly, so it can generate that kind of alert, right? Because the sensor, we have the sensors in a vehicle that they may actually detect it, but it might, like those sensors that we have, there are some delays or anything, they might not affect as fast as possible that goes to the control. So this can be some another way to help with that. So then it has like intersection movement assist, and it warns if the of like cross traffic that the vehicle cannot see, and like blind spot and lane change warning. So this is something that vehicle can exchange information and help each other which that, and an emergency electronic brake light warning. Now, the next category is vehicle to infrastructure, right? Or it is called V2I. So it enables vehicles to exchange real-time information with intelligent roadway infrastructure. And as we said, like um, the information exchange is like roadside units, message signs, toll systems, highway sensors, so they can exchange information with the vehicle and work with that. Now, the impact of vehicle to infrastructure, it can reduce intersection collisions, it optimizes traffic flow, and enables eco-driving strategies. So this is how important is that. So another category that we have is vehicle to pedestrian. So, and it's a communication that allows the vehicle to detect and communicate with people using some wireless signals. And those signals can come through the smartphones or some wearable devices. Like the information that can be shared is through the GPS, direction of movement, and like trajectory estimate, like where they are moving, or what the path they are planning to go, which is related to the direction of movement as well. So it protects vulnerable road users, right? Like if there are some bikers or other people, and it can help like people with disabilities, uh, that vehicles can be aware of that and not just consider them as a um, you know as some um, sort of the pedestrian that they because they may have lower speed or something like that. So vehicle can understand, can have more like understanding about that kind of the situation. Okay. Now, another category is the vehicle to network, which enables vehicles to communicate with cloud and cellular networks for like wide area data exchange. Um, and the data exchange is like map updates, traffic and congestion data, fleet management data. So it exchanged actually V2N extends communication beyond local range. Like, V2I, V2P, V2V. These three categories, even though they are like they help the vehicle, they cooperate with the vehicle, but they are mainly in the local range. But vehicle to network will support like some like areas or some range which is beyond local range. It can give information about wider area range. And and again, V2N is not typically used for immediate critical control. Like for example, in V2 we have that kind of the emergency braking or in a vehicle. So V2N doesn't work with that. Now, so communication is critical for traffic safety, right? And it refers to vehicle infrastructure and road users that they exchange real-time information to prevent crashes and reduce roadway risks. So, and even though the AVs they rely on their sensors like cameras, radar, and lidar, um, but they are not enough. Okay, so um, to improve the traffic safety, they can receive warnings from other vehicles. They can receive signal timings information from intersections. So they can detect pedestrians and their kind of the situations through V2P alerts, or they can receive weather or like some hazard warning through V2N. So this is how the communication can help with traffic. It also can help for mobility and efficiency, right? So it can improve the traffic flow. It can help in reducing the congestion and optimizing transportation systems. So when the vehicle exchange information with infrastructure or through the signals that they get through their sensors, they can optimize. They can all those data can be used to optimize traffic signal timing, adjust the speed to avoid like some red lights, uh, coordinate vehicles, provide real-time congestion routing, and support network-wide traffic management. Right, so that is what it helps in the um, the mobility. Now, so communication has a lots of benefit, and it's essential part of autonomous transportation, right? It's critical. However, there is the some concern because many of this communication, when they go through like what, especially to the wireless system, so when they connect it to some network like Wi-Fi or some like other kind of the wireless technology networks, then there are some concern of the cybersecurity because like if some attacker get access to the network, so it can manipulate the data and then completely affect the the performance of the vehicle, right? And so, and this is what the concern about the cybersecurity and protection is a critical area in not only in the autonomous transportation, because the cybersecurity can happen everywhere, right? In the power system, in your many of the utilities that they work, some sort of the communication between their sensors and controller. So it can happen everywhere and it can happen in many industries, right? So, and that is what it's a critical topic, especially in autonomous transportation, because the vehicles and autonomous vehicles, they are like moving in the roads and they have communication, they are in contact with people, right? So, and if somebody take control of the car or take control of the information or affect the data that's going to the controller to the perception, the car may show some uncertain behavior. So this is what the cybersecurity, the all the way can we have to make sure that and everything is the way that it happens is that all those attackers, they try to penetrate to the network and then change the information, manipulate the information. So that is what the cybersecurity is critical in communication, especially in AVs, and having a secure network, it will protect the vehicle communication system from some some certain attack, like message spoofing, like fake safety messages or fake information about the traffic congestion or make the traffic congestion or denial of service attacks, which actually removes uh, the information completely removes the access of the car to certain information from the infrastructure or other vehicles, or some unauthorized access to certain data or certain information, or some signal interception, get access to those certain data, and that kind of the cybersecurity and having the secured communication can help the the vehicle from this kind of the attacks. So these are just some part of it. Like there are so many ways that the attackers can get access to it. Now, and the protection method for that, there are so many ways, like having some digital signature authentication, public key infrastructure, encryption, like the data which is exchanged, they are encryption, like having some secure hardware module and having some intrusion detection systems. So these are protection methods, even though they are available right now. But we know that the attackers are also some intelligent actually entities, and they can find some way to penetrate to the network, and that is what it's ongoing research area to improve the safety of the autonomous vehicles. Another important aspect in the security is a privacy, right? So privacy is to make sure that the AV will not expose the driver identity, like location history, and personal travel patterns. So, because if some attacker get access to this kind of information, um, now they can do a lot of things with the some people's identity, their location of, or if they know that some person like is traveling in a certain days on a week, and so that pattern can give some flags to the attackers or other people, um, that that can affect the privacy and safety of the driver. So these are all they are required to make sure that everything is safe, secure, and able for the driver to use the AV or some you know um, if like we have some um, driverless AVs that some people use that, so the identity of those people should be also secure. Okay, so that is all for the communication systems, and there are some references. I put it here if you are interested in that. So this is everything, and I hope you enjoyed the lecture. Um, Thank you.